And welcome to the Daily Space Weather Show. It's getting hot in here. When I say here, I mean the photosphere. It's exciting times for space weather continuing here at the Smash News Network, least busted name in news, and thanks for tuning into the world's most comprehensive daily space weather content. Welcome to space. That's the past 24 hours. And we've had multiple flaring events both at the southwest and the southeastern limbs. Likelihood of an X-class flare is extremely high, especially in the western limb, but like I said, some activity in the southeast as well. Sunspot number here over 280 as we approach 300 sunspots. And just a quick note, are you familiar with the Hertzsprung-Russell diagram? Yeah, the Hertzsprung-Russell diagram. You got to understand what that is if you understand the concordance model of stellar evolution, right? So everybody who dislikes the concordance model of stellar evolution needs to know what the Hertzsprung-Russell diagram is. So the sun lies in the middle of that. Now that there's a reason for that. It's partially because we use the sun as a yardstick to compare other stars. So you can find that all over the place. It's a G-class star, and what that graph is showing you, it's showing you the hotter stars on the left, they are blue. The colder stars on the right, those are red. And then, of course, you've got the luminosity is scaled on the right side on the y-axis, and then on the left side y-axis, you've got the absolute magnitude. So, of course, the hottest, brightest stars are blue supergiants. And anyway, just a little side note there. Heliophysics is the basis for all of cosmology, so it's part of the reason why we do these videos. And getting back to the daily space weather here, we've got a high likelihood of X-class solar flares. Not so much from that group as from this group. And we've got as many as 18 named sunspot groups on the Earth-facing portion of the solar disk right now. Like I said, it's exciting times for space weather. So yeah, don't be surprised to see an X-class flare. Here's 304 angstroms, the ionized helium wavelength. And again, though we did see at least one M-class event from that southeastern sunspot, we'll have plenty of time to look at that. But this one here is going to be setting in the next about 3 or 4 days. And for that next 3 or 4 days, it's going to be a very high likelihood of X-class solar flares. So there is our equatorial zoom in the house favorite wavelength. Got to have the 171 angstroms. Otherwise, what are you doing? What are you doing? So yeah, there's 94 angstroms. And let's move on to volcanoes and earthquakes quickly. Luotobe is erupting. There it is. Luotobe. Also Luitolo, Semeru, Tocono, Santiaguido, Fuego, Sangay, Revenador, Sabancaya, and let us know which volcanoes are on your bucket list. As far as earthquakes go, most of them have been occurring around Taiwan. It's looking like an aftershock. So these are aftershocks here, looking like probably not foreshocks. We're hoping that a 6.3? We're hoping that wasn't a foreshock, but lots of 5 and greater magnitude events there around Taiwan. Looks like a 5.8 may be the largest quake of the past 24 hours. Taiwan, it's shaken and then shaken some more. Besides that, Philippines had a 5.3 just south of Taiwan, and Mid-Atlantic Ridge had a 5.0. Also at the tri-plate boundary there between the North American, the African, and the European plates. Near the Azores. That 5.2 occurred at 1540 Universal Time. 10.7 centimeter radio flux, which is a measurement of the radio flux density coming out of the upper chromosphere and lower corona. That's now 227 solar flux units, 227. Not to be confused with the Jefferson spinoff. So there it is, 227, the black line there, that's the past year of the radio flux. And of course we're breaking out because we're still like 5 to 6 months out from solar maximum. So you could expect to see higher and higher numbers here. as we approach 300 sunspots. Sunspot number here over 280. 280 plus sunspots. And NOAA is calling for some geomagnetic unrest, although no explanation of why. You can see here late in the day on the 25th, you can see KP4 is forecasted there by NOAA, but their Enlil spiral does not reflect that. So not sure, that could be the coronal hole high-speed stream, or that could be a CME impact. And by the way, as far as the European Space Agency, they agree with our forecast yesterday. Once again, we're on the same page with ESA. So there you can see another CME impact showing up there on their Enlil spiral. And now there will be another one, because another one launched this morning, early in the morning. So now another one will be likely to arrive sometime around the 25th, maybe late in the day, 25th into the 26th. We'll show you. But first, Earth's magnetic moment from space here, and things have been very calm. So the solar wind has been low and slow, low density and slow speed. And so very low pressure around Earth to about 12 Earth diameters, which is what's depicted. The past 4 hours of Earth's magnetic moment from space to 12 Earth diameters. Ground magnetic perturbations map is looking like this, and it is quite chill. So no geomagnetic storms, low likelihood of aurora at mid-latitudes. Of course, some of the places like northern Canada, Iceland, Greenland, etc., Alaska, can expect to see the aurora. Fairly normal aurora, just nothing spectacular. KP is KP 1.67. That is an average of global geomagnetism, by the way, if you weren't aware of that. KP index. When you see 4, you're at geomagnetic unrest. And when you're at 7, you're at a G3 geomagnetic storm. So here's the data from ACE as it orbits Lagrangian point 1, about 1 million miles from Earth. Very diffuse solar wind and below 400 kilometers per second. As far as Discover, also orbiting L1, much higher speed there. 6 protons per cubic centimeter, nearly 500 kilometers per second. And we do see some signals in here. I mean, you're seeing some field variations there. It looked like we were getting some interesting negative BZ action, but pretty weak fields. A field of only 5 nanotesla there and only 6 nanotesla over here. So pretty weak fields there, no strong signals. It's been pretty weak as far as space weather. GOES magnetometers here are smooth, so consistent with the relative lack of significant impacts, but all the impacts that were rolling in were shown as minor ones. By the way, the next one is going to be a major one. We're looking for a KP7 from the one that we'll talk about later in this video. Yeah, KP7 coming, folks. Aurora at mid-latitudes. But before we get to that, let's talk about Earth's magnetic sector. The sector of the heliosphere in which the Earth is currently located. And Earth is just right in a North Pole sector yet, so no changes likely coming there in the next 24 hours. There are the sun's magnetic fields. Photosphere magnetism, solar B field, and polar fields, all depicted there. If you don't know which is which, ask in the comments. Here's our coronal hole line of sight field plot. Line of sight coronal hole field plot there. Solar B field once again depicted in blue coronal holes. North are green, south are red. As the uptick continues in coronal holes and sunspots, exactly as forecast. So next thing we'll show is coronal holes. Yeah, coronal holes, and then it's on to sunspots. So like I said a couple of days ago, we've got this transequatorial one here. And that is actually all connected to a North Pole-oriented coronal hole. So if you see that whole thing, that's all North Pole-oriented, as you can see there. So that one may cause a little bit of uptick in space weather. Expect a high-speed wind from that for a limited period of time, something like maybe 36 hours. 36 hours or less. Shouldn't be a super extended coronal hole high-speed stream if we do see a big signal from that. And next, it's on to sunspots. Yeah, like I said, sunspot number here over 180. Over 180 for the sunspot number. There it is from Royal Observatory, Belgium. Flare probability extremely high. Again, mainly on the western limb, but also seeing some action there in the southeast. Here come sunspots. Again, those are the groups to watch. They have not significantly degraded. They still have complex magnetic fields. They haven't significantly grown either, but their proximity to the limb raises the base statistical probability of them producing a large solar flare, period. I believe it's something like 5%. Correct me if I'm wrong. Yeah, and look at the magnetic shear there. So where you see stark white and jet black right next to each other, those are going to be the most likely places to see large solar flares. Like that leading edge, there's some stuff in the southern portion of it, which is where we've seen a lot of action. And there's the full disk. That is today, April 23rd, 2024. That is what 280 plus sunspots look like. Dag! That is a lot of sunspots. Dag! Dear God! Thank God the Smash News Network least busted name of news is here to provide rational coverage of said sunspots. Now, a brief note about cosmic ray flux. So, we don't really know how to forecast cosmic ray flux. Why? Because it's entirely dependent on solar cycles. So, we don't know what the inputs for the solar dynamo is. The solar dynamo is what drives the solar sunspot cycles, and the solar sunspot cycles is what drives the plasma, and the plasma is what drives the cosmic ray flux. So if that's not convoluted enough for you, we can't forecast cosmic ray flux, because if we could, we'd also be able to forecast solar sunspot cycles. But we can't, so I just figured I'd bring that up. We'll cover cosmic ray data tomorrow. And if you enjoy the content, press the like button, press share, press subscribe. Tell your friends and foes about the Smash News Network least busted name of news. Just made new business cards today. You'll see them coming soon. Sliding across the screen. Telling you to join us on Instagram and on X and on Facebook, and to press the share button, and to remind people that if they don't press like, their souls may be cast into an ever-deepening and darkening abyss of doom, destruction, and diarrhea-mouthed nonsensical YouTube content. Good luck with that. Goes proton flux here is flatlined. No solar energetic particles. Doggone it. But the likelihood of that is rising as well. So 3 M-class solar flares today, to date. 3 M-class solar flares today. Let's take a look at them. From, hey, how about from the SDO? I think that's okay. What do you think? There's our 94 angstroms wavelength. A 24-hour video at 30 frames per second. How sweet it is. And yes, while mankind is ignorant of all kinds of things in the universe, complaining about our access to data about the sun is quite laughable. Wait till you see today's astronomy photo of the day. Chemtrails over Turkey? Is it? Is it? No, it definitely isn't. Since that's not a thing. Chemtrails, not a thing, but people swear that they are, because they don't understand meteorology or aircraft tech. Here's that sunspot up close. Ah, yes. Good time. So it looks like 2 of those 3 M-class flares came from that one, and 1 came from the southeastern limb. I've determined this through process of deduction. There's 131 angstroms. It is good times for space weather. Good times for space weather. And if you were worried the sun's shutting down, well, you can stop worrying, because it's clearly a much stronger solar cycle than solar cycle 24, as many folks figured out a short way through solar cycle 25. Solar system forecast is next. People want to know where planets are. They're convinced that planets underlie the solar sunspot cycles. They don't. The planets don't orbit the sun, right? The planets orbit the barycenter of the solar system, just like the sun. The sun and all the planets, they orbit the barycenter, their common center of gravity, right? The location of the barycenter, that's what drives the solar sunspot cycles, right? 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 No. But I think we're making a video about that. We'll keep you posted. Here's your solar system forecast. That's where things will be in a week. Here's what's going on over our head. We're located in Lehigh Valley, Pennsylvania. Shout out to our viewers from all around the planet, all around the universe, all around the plane of existence, all around the timeline, all around the whatever your reality is or isn't. Wouldn't want to be bigoted about your reality. Anyway, check it out. Here is the chemtrail of the day. The apod.nasa.gov. A giant X in the sky. X marks the spot where there's a shadow cast by a couple of contrails. Persistent contrails. So, okay, all of you chemtrail people, you can all pipe up now and say, look, they were spraying while the sun was low in the sky and while there were high cirrus clouds on which to project a shadow. By the way, folks, the most common thing you'll hear about chemtrails is that persistent contrails are proof that they're spraying chemicals out of planes. Well, guess what? Persistent contrails have been well documented since long before World War II. So maybe they were trying to block out the sun back in World War II, right? apod.nasa.gov if you want to check out the astronomy photo of the day, which is certainly a meteorology photo. And by the way, it actually goes so far as to say that contrails, and this is a fact, by the way, contrails make the planet warmer at nighttime and cooler in the daytime. Why? Because clouds, including artificially generated ones, they emit infrared radiation, otherwise known as heat. So they emit infrared radiation. That causes... You ever notice how a cloudy night is kind of warm? Yeah, that's why. Because the emission of infrared radiation. In the daytime, they reflect light back into space. So, a little bit about how clouds thermally affect the planet. The albedo effect in the daytime and the greenhouse effect at nighttime. Of course, they're emitting the infrared radiation in the daytime as well, but I digress. Coronal mass ejections are next, and early this morning we had another earthly directed one. This is going to be a major impact. So it might not look like anything too special on there, but guess what? It came almost from smack dab in the very center of the solar disk. So right in here, you're going to see it, right? You're barely going to see anything, actually. So, but right in here, you're going to see some stuff coming out of the south. And at the same time, there's a CME headed directly toward Earth. It's... Like I said, we're going to have a KP7, so get ready to see the aurora big time the night of the 25th into the 26th. So that's Thursday night into Friday. CME impacts are coming. We'll also show from stereo A. There you can see that southerly ejecta. Part of that is an earthly directed ejecta. I don't know what else to say. But let's move on to our custom coronagraphs because they're totally sweet. Dude, the Smash News Network least busted name of news. Do we not provide the most detailed imagery and comprehensive daily space weather in the known universe? Now, as we zoom in closer, you'll see where that CME came from. Part of the filament did collapse. Part of it ejected right in here. You're going to see a brightening almost directly in the Earth-facing portion of the solar disk. That brightening is a Hyder flare as some plasma splashes back down toward the lower reaches of the solar atmosphere, the lower corona, the upper chromosphere, etc. Some of that ejecta is on the way to your back door. So we'll move in one more step here as we wait for ESA to update their Enlil spiral once again to show that extra spike. So we don't see a lot of limb darkening there, if any. But I believe we will see a filament vanishing. So let's check that out next. We'll move on to filaments. So there we go. And again, that CME was from this area right here, and you can see a filament is there, and then it's gone. You see it? It's right there. And whoops. Now it's gone because it's on the way. So that one didn't just entirely cave in. Part of it relocated and then caved in. Part of it ejected. Period. I mean, don't believe me? Wait until the 25th into the 26th and we see a major geomagnetic storm and people say, I wasn't aware that there was going to be a thing. I hear channels that claim that they cover space weather every day, and what do they really do? What do they really do? They show you images and they say, look, I'm not even going to suggest, I'm not even going to try to imitate what they say because it makes no sense. Oh, and by the way, we have enough filaments that I'm taking the reins here, and we are going to name a filament before your very eyes. So just follow the hashtag name that filament over on Twitter, and this filament right here is going to be known as the Larry David filament. Larry David is not on Twitter. You saw it on the video, this one right here. It looks like an eyebrow. Perhaps like Bernie Sanders' eyebrow. That filament named Larry David. Follow the hashtag name that filament on Twitter. Name filaments after your friends, your foes, or even yourself. Let's blast through bonus features. There are the past couple of hours and lots of activity indeed. Not just sunspots, not just solar flares, but huge filaments blasting off. The likelihood of CMEs going into tomorrow is nearly 100%. Satellite charging hazards are minor. We do have some over the northern Indian Ocean. There you go. GOES electron flux here. Oh, the GOES 18 is moving into warning levels. That's not going to cause any real harm, but it might cause some additional charging hazards there. There's the past year. It's just moderate levels of electron flux, nothing to worry about. Here is the forecast model, and NOAA's expecting a dip, and so are we, because there are more CMEs on the way. We'll show the ionosphere, the layer where it's measured. That's the F layer. It's located at about 300 kilometers of altitude. That is showing megahertz, which would be millions of vibrations per second. It's a bunch of diffuse gas reverberating as a result of things like incoming radiation and outgoing radiation and heating and all kinds of electrodynamics. The ionosphere at the F layer. Outside the bridge between Earth and space. Yes, that is in space. That is Earth's atmosphere, the part of it that protrudes into space. There's the anomalogram, anomaly in megahertz from a 30-day median. South Atlantic anomaly there, very obvious over the center of the South American continent. Next is Global Ionosphere Nowcast. That'll show you GPS errors on the left and radio frequency usage on the right. It's meteorology time, and we're stepping on the gas. So there's a solar disk. It's got a lot of sunspots, like I said, over 280. As far as meteorology goes, there are the sea surface temperatures, sea surface temperature anomalies, and ocean currents. We're just going to skip all of that. We're going to move on to satellite imagery. There's the satellite imagery for the North American and South American continents. The Americas, the Western world, as a low swirls around in the North Atlantic south of the Azores. But did you know that Windy.com has a fantastic satellite imagery? It'll even seamlessly transfer it into nighttime if you want to see if there are clouds. Windy.com, they got a great mobile app that's great for the novice. If you're not looking for ultra in-depth information and customization, Windy.com's mobile app will do you right. Like I said before, I say it once more. Windy.com will make your forecast so good. It'll do you right. Now, there's our weather.gov advisories. Weather.gov is where to get your warnings. Here come a couple of forecasts. Temperature anomaly in degrees Celsius. 72-hour GFS model. Cold air coming back to the northeast. Pressure and precipitation's next. Lots of moisture coming to the Pacific Northwest, as well as a low forming over the middle of the country. And then making a bit of a left up toward the Great Lakes. There's lightning for the past 10 hours. Here's a real-time lightning map courtesy of lightningmaps.org. Lightningmaps.org. Highly recommended. And we do have some Great Lakes lightning right now. It looks like a bad time to be out on Lake Huron. Dag! There's thunder rolling in at the Misery Bay Provincial Park. Here's your Doppler radar. U.S. satellite for the lower 48. And the water vapor map. Here's your recap. When your Doppler's unclear, use the water vapor. Understand atmospheric physics and meteorology and aircraft tech, and you won't believe in chemtrails. There are the satellite images. I don't really care if you believe in stuff that doesn't exist or not. It's just sad that people waste so much of their time and energy trying to convince others of non-existent phenomenon. Anyway, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And until tomorrow, may that solar wind be at your back.